All right, week 3 begins. All right, where I'm going to start with is with the whole notion of ourselves as being beings in this world and in need of information about the world around us. So we talked about how 3 lobes of the brain, how their primary job is really about sensing the world around us. And so I want to begin with that, and I want to talk about that process right from very early stages of sensation, but all the way to including things like concepts like attention, concepts like consciousness, and the notions like, well, what happens to information that we're not attending to? Do we still perceive it? Does it still get in? Does it still influence us? So I've kind of called this outside in because that'll be our focus for the remainder of this week. All right, let's get going. Week 3, Lecture 1. Nice 5 senses all overlapped into one on this image here. All right, so here's this kind of profound thought that I have every now and then, and it kind of freaks me out, and so let me share it with you and see if it freaks you out as well. We are made up of all these little molecules that organize into things like nerve cells and all that, all this living tissue. But somehow something special happens somewhere along the way. A bunch of this living tissue gets covered in this membrane we call skin. And suddenly everything within that skin begins to think of itself as an entity, as a distinct thing from the world around it. And in fact, it really is. We are this being that's locked within our skin with a world all around us, and that world is sending all this energy out to us. We have the perception that what we see, what we feel, what we smell, what we hear, and what we taste is all there is to the world. But in fact, that's simply not true. There is a lot more energy out there, a lot more information out there than we are ever aware of. So, here's a couple of examples to get you thinking about that. When you watch those spy movies and stuff, and they'll show infrared heat sources, there are these detectors that can detect temperature. And we can turn those into visual signals, so you could wear glasses where you can actually see heat sources, or we can put them on cameras and things like that. But those heat sources are there all the time. We are normally just insensitive to them. We cannot feel the heat of the bodies around us or see them or sense them in any way until we get to a point where we can actually touch them. Our heat detectors are what we sometimes call proximal, very close detectors. They're not distance. So that's just one example of light energy in that case, because it is light energy, but it's out there, but our eyes are only sensitive to a thin band of the light energy that's out there. As another example, radio waves, for example, are all around us all the time. If we have a radio receiver, we can tune it into a certain frequency, and that receiver is then able to take that energy that's around us and turn it into an auditory signal that we can hear. It can do, again, that sort of translation process of taking something that's beyond our senses and moving it into a world that's within our senses. But it's there all the time. Radio waves surround us constantly. We are just impervious to them. So what we know about the world, we know from the senses we have. And it's a really fascinating question of how energy from the outside world becomes some sort of representation in the inside world. Something that we think of in terms like a bottle or a chair or a jacket. How does energy from the external world become something we see as a jacket? Fascinating. That's the big philosophical point. When we start to think about that in scientific terms, we can break this down, this process, into a few steps. And I'm going to use this just to give you a sense of some of the issues that we're going to be talking about during this week. So over here, I'm going to start with the world. The world is outside of us. Okay, we have these specialized detectors, for lack of a better term, these things that sense energy of different sorts, like our eyes, ears, nose, mouth, our sense of touch, I even mentioned, by the way, our proprioception earlier, our sense of where our bodies are. We have all of these sensors giving us information about the world around us and even our body within us. Now, that energy has to somehow go through these sensors and become a neural signal. I told you that everything in the body, all information, is transmitted by firing of neurons. How does the energy turn into neural activation? Well, that step, that's what many of our sensory apparatuses do. That step we call transduction, transducing physical energy into a neural signal. So that'll be one of the first things that we talk about. That leads to something we call sensation. Now, I say sensation because I'm worried, just as I look at this diagram, of things sort of following this nice little step by step process, because it really isn't like this at all. Sensation and perception, as we'll come to argue, are really a loop that's happening, where information from the perception side of things is informing sensation and vice versa. But we'll talk about it in this way, at least, where we'll talk about sensation first. Sensation meaning just the picking up of raw signals from the external world. The difference between sensation and perception will have to do with the recognition of what that is that you are seeing, hearing, smelling, tasting, etc. So perception implies what you recognize things as. And in fact, when we look at the world, we tend to be overcome by perception. We tend to see cars and people and trees and buildings. All of that is perception, as opposed to shades of green, shades of blue, sounds of this frequency, sounds of that frequency. That's more sensation. And let me make that distinction a little bit clear. If any of you practice photography, one of the things most photographers notice is when you start taking pictures of the world, you suddenly become very sensitive to things like light and shadow and various other visual effects in the case of picture. Motion, say a stream moving over rocks, where you think, wow, if I open my aperture a little bit, that will cause this really cool look. You become more sensitive to the sensory level, that raw sensory level. So you'll look at a tree and you'll look at the way the sun is playing through the leaves, and you'll think, wow, if I took a photo of that, that would be really stunning. It would be really beautiful. Okay, that level of light and color and raw information is normally what we talk about as a sensory level, whereas the categorized version of that takes that and just says that's a tree, maybe even that's a tree in the fall, that's what we call perception. This may still be a little off for you, a little vague. It'll come more clear as we go. Okay. Now imagine that you're perceiving a couple things at a time, and we are. This is going to be a very interesting aspect of this chapter. We are bombarded by stimuli at all times. We're bombarded by sights, by sounds, by tastes, by smell. We cannot, seemingly, be aware of it all the time. There's a limitation in the human cognitive system. In fact, it seems often that we can only be aware of one thing at a time. Maybe that's a little extreme, but it's closer to reality than the everything notion is. It seems like we must focus our attention. So somewhere in this perception, at this perception stage, there's a bit of what we'll call selection happening, where certain sensory inputs will be favored and will ultimately lead to a clearer perception than others, even though we're equally exposed. So we could be looking at this beautiful skyline of Toronto at the same time as we're hearing some song, but we really get captured by this and we really pay attention to it, and somehow the song seems to drift into the background. Okay, all of this implies some role for that thing we call attention, and we'll be talking about attention a little, and I'll show you some really cool phenomena with attention, and all of this will lead to a distinction that'll be pretty interesting and important. The idea that to which we attend, we become aware, we become conscious of. But what does that imply for the stuff we're not attending to? Is it just gone? Is it just filtered out? Or are we still perceiving it at some level, and is it still influencing our behavior in some way? Okay, these are going to be the big issues. Now I want to kick it all off and get your mind going a little bit by this fascinating phenomenon. The phenomenon of phantom limb pains, because what I want to use this for is to remind you that ultimately, even though it looks like the world is out there and everything's out there, it's really in here. Okay, this is where the rubber meets the road, as it were. This is where the world is represented in our minds. And I think this is a really good stark example of it. Imagine this person was a soldier that stepped on a landmine, and as a result had to have their leg amputated from this point on. Virtually anybody who's undergone an amputation will suffer from these really horrible and perplexing things called phantom limb pains. So this gentleman might go see a doctor, and he might say, "Doctor, this is really embarrassing to have to admit it, but you know I have no right leg from the knee down. I know I have no right leg, but I have to tell you, my right foot really hurts sometimes, like excruciating pain that comes from my right foot. And yes, I know I have no right foot, but that doesn't change the sensation I'm having of extreme pain." Now, by now, I hope you got a sense of why that could be. It's because this right foot and the sensory information that comes from it is actually received by that sensory strip, rather, on the left side of the brain. And just because you lost your right foot, you did not lose that sensory strip. If that sensory strip becomes stimulated, and it can become stimulated because an area right beside it became stimulated, or it can be stimulated from random activation in the brain. If that becomes stimulated, it will feel to you like a pain or an itch or something in your right foot, even if you don't have a right foot. Because ultimately, the feelings that we feel originate here from our somatosensory cortex. They don't originate here. The pains or whatever here are sent to the sensory motor signal, and this is the part we feel. So if this is stimulated in some other way, we still feel the pain or the itch or whatever. Fascinating. And it really shows that it's the brain where things matter. Okay, there's a lot to this phantom limb pain, and I could tell you more about it, but I'm going to leave it to a couple of the experts in the field, and I urge that you check these out. So one is Ramachandran. We've talked about Ramachandran before. We'll probably talk about him again. He just does really fascinating stuff. So check out Ramachandran talking about phantom limb pain, and you'll get some of that somatosensory cortex story, and also Oliver Sacks, who I've also talked about already. Check that out, and then check out how they're using mirrors to kind of trick the brain and thereby help people suffering from phantom limb pain. Really kind of fascinating. On the reading side today, I just have a website that's got some illusions that you can check out, and it walks you through these illusions. Illusions are kind of important for this sensory perception part of things, because one way of knowing you understand the brain and how it's sensing the world is to find ways of tricking it, and then studying, well, why do the tricks work? And often doing that tells you a lot about what the brain is doing. So to kind of feed your mind for some of the topics we're going to be talking about, I give you this website on illusions. So check out some of them. They're cool. Share them with your friends. Okay? All right, so we're going to have a fun week. I look forward to spending it with you. I will see you in Lecture 2 in a little while. Bye-bye.